Hi, kids. Welcome back. We've got a problem today. It's called hexagons in a row. It's all mixed up on this one, but hexagons in a row, and we're talking all about like number patterns. So it says that down here. This problem gives you a chance to find a pattern in a sequence of diagrams. Use the pattern to make a prediction. Yeah, that's what we're talking about. Like number tables, XY tables, growth tables. They help us predict what's going to happen next. They help us predict what's going to happen down the road or in the future. So if you're talking about something over time, what's going to happen next. If you talk about something that's growing in some form, then it's talking about like what's it going to grow to, right? So we're predicting. We are using patterns to predict. So this problem says Joe uses toothpicks to make hexagons in a row. And in the first in the first drawing, as you can see right up here, I better turn it to my right thing, he made a single hexagon. This is called a regular hexagon, right? And that means that it has 6 sides and all the sides are the same, all the angles are the same. It's a terrible looking hexagon that I just drew over it. But the idea is that each one of those is a different toothpick, right? So every single one that I drew in that order, see, one, and then I drew two, and then I drew a third one, and then a fourth one. Each one of those is a toothpick. So now that means we have 6 in the first hexagon. If I want to make this, I'm making it out of 6 toothpicks, right? And here's our table. Number of hexagons in a row, number of toothpicks. Now in the second one, right, we're going to grow this thing. So we already had the first one drawn, right? We already had this one in blue already drawn. And we're going to add to it. So when we add to it, we're not going to make a second toothpick there. We're just going to basically, let's change the color. Let's make it darker blue, right? And what we're going to add is we're going to add the next one right next to it. Notice that these two hexagons share a side now, right? So there's already a toothpick there. We don't need another one. That's kind of interesting. So how many toothpicks are there in the second row, right? Which means this row, the second iteration or the second kind of like part of this problem or the second kind of model that we've made. We're going to have 6 hexagons right here and then 1, 2, 3, 4, 5 right there, giving us 11, right? So we're noticing that it's going up, but it didn't hit 12. You would have thought, oh, 2 hexagons, 12, of course. 3 hexagons, 18, 6 times 3. Not true. Not true. Doesn't happen, right? Because look at this. We only added 5 toothpicks. Interesting, right? And the third one, we do it again, right? We are adding. What are we adding? So instead of me tracing the whole thing, I'm just going to show you the part we're putting on. We're going to need, we already have that first part. We're just going to need 1, 2, 3, 4, 5 more. And look at that. They already give you an answer. 16 toothpicks. Here we go. We better write that in. Number of toothpicks. 16. I like how they make this so difficult that they actually tell you the answer here and all you got to do is write it there. Wow, they're really challenging you here, aren't they? Okay, I know that was hard, guys. Good job. Okay, 4 hexagons. What's happening, right? So we want to keep looking. Like we keep noticing a pattern, and we can start to look at the number pattern. What's happening in the number pattern? Pretty interesting. This is how this works. You find a pattern, and then you know that it's going to continue and continue and continue. And if we can keep track of something, it's going to keep going. So what I would recommend is that on your table, which you do have to draw into your notebook, you absolutely, completely must draw that table. I think you should basically extend it. I'm going to make a recommendation here, kind of like I did. I think you should extend that table. And what I would do is like, why not? Like extend this thing out, right? And put in their 5, put in their 6, because I'm guessing, you remember how we said these predict the future, or they predict what's coming next? You can keep going. 5, 6, 7. How many different iterations are there? If this is 1 hexagon, 2 hexagons, 3 hexagons, 4 hexagons, then how many when it's 5 and 6 and 7, right? So we can keep going. Now, another thing I wanted to show you is that you can also draw a table like this vertically. We could have also just set up a table. If you didn't have one that they already gave you, you could have also set up the table this way and done the same information. So this is the number, and I'm just showing you, of hexes. I'm just going to put number of hexagons, right? Number of hexes, right? And then over here, you could say toothpicks. So this side is number of, right, toothpicks. Toothpicks. Now, this gives the same information. And all we do is we'd set it up like 1, 6, 2, 11, 3, 16, And I like the vertical ones, but it doesn't matter to me. Four, and then you tell me what's next, what's coming next, right? And you can count them. I mean, we could also just count them, right? But I'm not gonna. I'm gonna let you do that. So now I'm gonna go to the second set of problems, which work with this same idea. And on the second set of problems, they say, how many toothpicks does it take Joe to? Does Joe need to make 5 hexagons? Oh my gosh! Didn't I tell you to extend the table? Look, we've already done that. We can figure that out. Oh my gosh, you're right there. That means you've almost got 2 done. And they say, how did you figure it out? You can say, well, I used the table and I predicted it based on the pattern, right? You knew what the pattern was at that point. And then number 3, how many toothpicks does Joe need to make 12 hexagons? Oh my. Now we're getting to be a big number. We said 5. I said extend the table up to 6. How are you going to get up to 12? Now, I'm going to give you a clue here. I wouldn't just double what you have at 6. It doesn't quite work that way. Okay, that's not going to work. So if you say, oh, I can figure out 6 and then just double it, it doesn't work. Okay, so see if you can figure it out, knowing that if you double whatever you get for 6, you double it, doesn't work. And then the last problem, which may or may not be extra credit, I'm still deciding. But I'd like you to do it either way. Actually, I shouldn't say extra credit. It's just like a little more challenging. It says Joe has 76 toothpicks. How many hexagons in a row can he make? So maybe you go get 76 toothpicks and build it. That would be probably the slowest way to do it, but it would be fun. Or we can kind of look at our table and say, where would that get us on our table? Maybe our table gets bigger to try to figure out what that is. Maybe you have a better way, but it's kind of like working backwards. Like if you know the number of toothpicks and you say, how many can I make? You might want to work backwards. But this problem is an interesting one. I'd like you to work on the table. Make sure the table is very clear on your drawing. I want to see that table. Like that's important. Like when I grade it, I want to see that table. I want it labeled. I want to show in the parts. If you extend it out to 6 and maybe even further, that would be a really good idea. And if you're really in super genius mode, can you figure out the rule from any number of hexagons? How many toothpicks would it be? Like if I said, what if I wanted 100 hexagons? How many toothpicks would I need? I know that because I know a rule. I figured out the rule. Can you figure out the rule? Do you know the rule? See if you can figure it out. All right, my friends. This cat. See, cat. There's the cat again. He's so cute. All right. Have a great day, guys. I hope you're having a good week. And that's it. I hope the weather's nice. Maybe it's snowing. Who knows? Bye, everybody.